So, no disturbance in classes, online digital lessons with HD quality transmissions, subject experts and experienced faculty. Unlike other app, we have our own teachers for assuring 100% quality education. If you too want our quality teachings are at your premises and institutions, not only SSC, but other various courses are in easy method covering state syllabus. We successfully taught at pre-examination period to government SSC students in COVID pandemic. We made grand success our online teachings at private colleges also. Why are you waiting? Just dial for online admissions. Rush and join in ABC Education Learning app.
Hello everyone, welcome to mathematics class of ABC Educational Learning app. Student, we discussed in previous class Euclid division lemma. Euclid division lemma. Already you know students what is mean by Euclid division lemma. If a and b are two positive integer, then must satisfy q and r the condition a is equal to bq plus r, where r exists 0 less than r less than b. Okay, this is called Euclid division lemma. Based on this technique, we will solve example problems how to solve using this technique. Now see problem. Use Euclid division lemma. Use Euclid division algorithm or lemma to show that square of any positive integer is the form of 3m or 3m plus 1. First, what is given question? Just understand what is the meaning of use Euclid division algorithm. Already we know Euclid division algorithm to show that square of any positive. Yesterday we discussed odd positive integer. Now square of any positive integer is the form of condition 3m or 3m plus 1. Okay students, already you know Euclid division lemma. Then how to solve this type of problem? First, let a be any positive integer. A be any positive integer. Next, what is the condition here? 3m or 3m plus 1. Then compare with Euclid division lemma by applying EDA, that is Euclid division lemma. A is equal to BQ plus R. A is equal to BQ plus R, where R exists 0 less than R less than B. Then compare with the B, where M is some integer. Then A is equal to, what is BQ? 3M. Then here, what is the value of divisor? Divisor is nothing but B. What is the value B? 3. When you know divisor value, then possible values of remainder. Possible values of remainder. Values of remainder. That is condition 0 less than or equal to R less than B. Means what is the value of B? Means R satisfied the values 0, 1, 2. Let's see case 1. See what is the condition here? Square of any positive integer. Then A is equal, A square is equal to BQ plus R whole square. Then you know students, what is the value of B? 3. 3Q plus R whole square. Students, you know A plus B whole square identity. A square plus 2AB plus B square. Then you can write here A plus B whole square identity. That is A square plus 2AB plus B square. Okay. Then now case 1. Just expand it. 3Q square is nothing but 9Q square plus 2AB, 2 into A into B, 6Q plus R square, right? Then case 1, R is equal to 0. Let case 1 R is equal to 0. Suppose it is equation 1. Okay. By using this identity, A plus B whole square identity, A square plus 2AB plus B square. Okay. Then substitute R in equation 1, we get A square is equal to 9Q square plus 6QR. 6Q into 0 plus 0. Students, already you know 0 into something? 0. Okay. Then 9Q square plus 0. 9. You can write 3 into 3Q square. In place of 3Q square, take variable M, where M is some integer. Therefore, is in the form of 3M. Is it clear, students? Where M is equal to 3Q square. Where M is some integer. M is some integer. M is some integer. Okay, students. Very important for your SSC examination question. Use Euclid division algorithm to show that square of any positive integer is the form of 3m or 3m plus 1. By using Euclid division algorithm technique, A is equal to BQ plus R. What is the condition R? 0 less than or equal to R less than B. Then here what is the value B? B is equal to 3. Then possible values of remainder 0, 1, 2. Now we completed case 1, that is 0. Then now next case 2, R is equal to 1. Case 3, R is equal to 2. Then how to verify it? By using Euclid division technique. Is it clear, students? Now case 2. Case 2, same R is equal to 1 here. Okay, students? In case 2, R is equal to 1. From equation 1, A square is equal to 9Q square plus 6Q. In place of R, substitute 1 plus 1 square is 1. Then 9q square plus 6q plus 1. From these two terms, common 3, then 3q square plus 2q plus 1. In place of 3 square plus 2q, you can write some integer, that is m. Therefore, is it in the form of 3m plus 1? Here 3m, here 3m plus 1. Similarly, case 3, in case 3, r is equal to, from equation 1, a square is equal 9q square plus 6q into 2 plus r square 4. Okay, then 9q square plus 6 to the 12q plus you can write for 3 plus 1. From these first three terms, common 3, then 3q square plus 4q plus 1 plus 1. From here you can take variable, that is m. M is some integer. Therefore 3m plus 1. Therefore is in the form of, is in the form of 3m or 3m plus 1. Is it clear, students? Okay, by using Euclid division algorithm technique, okay, just verify given conditions. Square of any positive integer, that is 3m or 3m plus 1. Okay, student, is it clear? Now next topic, fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Very important, students, for your SSC exam. Now next topic is the fundamental theorem of arithmetic. In this topic, already you know LCM, HCF, how to find of given integer, to find HCF and LCM of given integer. Next topic, fundamental theorem of arithmetic. Statement, very simple, students. The statement is every composite number can be expressed as product of prime factor. Fundamental theorem of arithmetic. Every composite number can be expressed as product of prime factor. Already you know, students, what is mean by composite? Composite number, the numbers which are more than 3 factors. Suppose number 6. Okay, what are the factors? 1, 2, 3 and 6. Number 6 have 4 factors. Then 6 is a composite number. Then any composite number we can express it in terms of prime factor. Prime is nothing but there is no common factor. Prime is nothing but 1 and itself. Any number divisible by 1 and itself. For example, take 5. What are the factors of 5? Only 1 and 5. Therefore 5 is a prime. Prime is nothing but any number divisible by 1 and itself is nothing but prime. Composite means more than 2 factors. Okay, see students, for example, let 45 45 is a composite number. Okay, by prime factorization method, already you know prime factorization method. Okay, 3 ones are 3, 3 fives are 15, 3 fives are 15 is nothing but 45 is equal 3 into 3 into 5. Here see here 3 into 3, when bases are equal we add powers, means 3 square into 5. You can write 45 is equal. Observe here, students, observe here, 45 is a composite number. We can express in terms of 3 into 3 into 5. 3 into 3 into 5 are prime factors. Okay, fundamental theorem of arithmetic, very very simple. Every composite number can be expressed as product of prime factor. Okay, 45 is equal 3 into, see one more example. For example, 36. Okay, 2 ones are 2 eights are, next 2 nines are, 3 threes are, 3 ones are, means 36 is equal 2 into 2 into 3 into 3. You can write 2 square into 3 square. Okay, 36 is a composite. Then in terms of prime factors, that is arithmetic, fundamental theorem of arithmetic. It is also known as prime factorization. Prime factorization. Okay students, by using this method, prime factorization method, to find LCM and HCF of given integers. Let's see how to find LCM and HCF of given integers. Okay, is it clear students? Every composite number can be expressed as product of prime factor. That is fundamental theorem of arithmetic. LCM and HCF. In lower class, already you learned LCM, HCF. How to find LCM, how to find HCF by using prime factorization method. Already know. But here we use fundamental theorem of arithmetic. How to find LCM and HCF. Now see, let's see LCM. Already you know students, LCM, least common multiples. Least common multiples. HCF, highest common factor. HCF, highest common factor. For example, find LCM and HCF of 72 and 108. Okay, by using prime factorization method. How to find prime factorization method? 72, 2 3s are 6, 12, 2 6s are 2 18s are 2 9s are 3 3s are. You can write 72 is equal to 1 2 3. How many 2's here? 2 power 3 into how many 3's here? 1 2, 3 square, means 2 cube into 3 square. Similarly 108, 2 5's are 10, 2 4's are 2 2's are 4, 2 7's are 3 9's are 3 3's are. 108 is equal to how many 2's here? 2 square into how many 3's here? 3 cube. Okay, then by this is the prime factorization method. Then how to find LCM and HCF? LCM, greatest power of, which is greatest power of factors, common factors. Greatest power of each common factor. Okay, greatest power of 3 square, 2 square. Okay, 2 cube into 3 cube. This is LCM. HCF, lowest power of each common factor of given number. HCF 3 square into 2 square, 2 square into 3 square. Is it clear, students? How to find LCM and HCF? By using prime factorization method. Already you know. You can take order of the factor, 2, 3, 5, 7 like this. Okay, then 72 you can write in terms of 72 is a composite, then you can write up in terms of prime factor. Then similarly 108, then how to find LCM and how to find HCF. Okay, see one more example. Is it clear? Find, second question, find LCM and HCF of 12, 15 and 21. By using prime factorization method, students, 12 already you know, 2 6 next 2 3s 3 1s 12 is equal 2 square into 3, same 15 3 5s 5 1s 15 is equal 3 into 5, next 21 3 7s 7 1s 21 is equal 3 into 7. Then LCM of 12, 15 and 21 is LCM 2 square into 3 into 5 into 7. Okay, 2 square 5 into 7, 4 3s are 12, 12 5s are 60, 67 is 420. LCM is 420. Same HCF is nothing but lowest common factor, 3 and 3. In 3 positive integer, which is lowest common factor? 3 is lowest common factor. Therefore, HCF of 12, 15 and 21 is 3. HCF of. Is it clear, students? Very simple to find LCM and HCF by using fundamental theorem or prime factorization method. Okay, is it clear? Very simple. Okay, now next, how to given questions in public exam. Just to verify given number is a composite or not. Suppose explain why 7 into 11 into 13 plus 13 is a composite, right? Explain why 7 into 11 into 13 plus 13 is composite. How to solve this type of problem? See, students, first observe in given numbers which any number is common is there. Observe here, given number 7 into 11 into 13 plus 13. Observe here, 13 is common. Then you can write 7 into, first common 13 into 7 into 11 plus 1. Okay, 13 into 7 11s 77 plus 1, 13 into 77 plus 1 78. That means when we product of two even positive integer, we get composite number. Therefore, given integer 7 into 11 into 13 plus 13 is a composite number. Suppose you can multiply 13 into 78, we get composite number. Right? One more question. We get composite number. See one more question. What is the last digit? What is the last digit of 6 power 100? Okay. What is the last digit of 6 power 100? See students, already we know that 6 power 1 is equal to 6. 6 square. 6 square is nothing but 6 into 6, that is 36. Okay. 6 cube is nothing but 6 into 6 into 6, that is 216. Observe students here, what is the last digit of 6 power 100? Observe here, last digit is nothing but unit digit. Then 6, here also 6, here also 6. Therefore, you can take 6 power n times. 6 power n times, we get last digit is 6. Therefore, last digit of given number is 6. Is it clear students? Very simple. What is the last digit of 6 power 100? We know that 6 power 1 6, 6 square 36, 6 power 3 216. Okay, like this 6 power n we get last digit 6. Okay, therefore last digit of given number is 6. Is it clear students? Very simple. Now next, rational numbers and their expansions. Rational numbers and their decimal expansion. Rational numbers and decimal expansion. Students, already rational number. Rational number is nothing but denoted with Q. Q is equal P by Q, where Q not equal to 0, right? Q is equal P by Q, where Q not equal to 0. For example, 2 by 3, 4 by 5, these are rational numbers. Means 2 indicates numerator, 3 indicates denominator. Similarly, here P indicates numerator and Q indicates denominator. Then rational numbers and their decimal expansions. Already decimal values. Then rational numbers can be divided into 2 types. That is terminating, non-terminating. Okay. Rational numbers, terminating decimal and non-terminating repeating decimal. Now see what is terminating and how to divide terminating given P by Q number. See, first terminating decimal. Let one example, 3 by 4. See here, 3 by 4 is nothing but P by Q. P indicates 3 and Q indicates 4. Okay, is nothing but how to it is terminating, how to we say it is terminating or non-terminating. Divide 3 by 4 is nothing but 4 divides 3. Okay, then it is smaller than divisor. Dividend is smaller than divisor. Then put here 0 point, here 0. Then 4 7 ja 20, 8. 30 minus 28, 2. Then already here decimal point is there. Then one more, right? And one more 0. Then 4 5 is 20. Okay. Then students, 3 by 4. What is the decimal value? 0.75. Right? Here we convert decimal rational to decimal. See here, P by Q is a 3 by 4 is rational. Then we convert into decimal. 3 by 4 we can write 0.75. Then how to convert decimal to rational? Okay. How to convert decimal to rational? Take, already you know, 0.75. What is that P by Q value? 3 by 4. You can take, see here, terminate. What is the meaning terminate? To stop. Terminate is the meaning to stop. Then the division process, when we get remainder, then process will be stopped. Okay. Then 0.75 you can write after decimal point how many digits are exist? 2 digits. Then 0.75 into 100 divided by 100, we get 75 by 100. Okay, here unit place 5, here is 0, then 5 table, we get 3 by 4. Clear students? Terminate is nothing but we get remainder 0. Okay, then P by Q is the rational. Then what is the decimal value? 3 by 4. Decimal value 0.7. Decimal 0.75. What is the P by Q value? 0.75. Then now you know how to convert rational to decimal and decimal to rational. Is it clear students? See here, it is a decimal P by Q value means rational value. Then by using division 3 by 4 we get decimal value. Here decimal we get P by Q value. Then without doing actual division we can directly say which is terminating, which is non-terminating. Let's see. Okay students, without doing actual division, see here, let x is a rational number, that is P by Q. Here Q indicates what? Denominator. Therefore here Q is in the form of 2 power n into 5 power m. When Q is in the form of 2 power n and 5 power m, then that is terminating decimal. Is it clear students? Without doing actual division. Okay, where n and m are non-negative integer. Okay, see, for example 3 by 4. What is value here? Q. Q is equal to 4. You can write Q in the form of, right? You can write 2 square. Okay. 2 power n is nothing but 2 power 2. Then what is the value of 5 power m, sir? What is the value? 5 power 0. Already you know students, something power 0, that is 1. Therefore, here Q is in the form of 2 power 2 and 5 power 0 is nothing but 2 power n into 5 power m. Therefore, 3 by 4 is a terminating. Okay student, is it clear? Without doing division we can say directly. Depends on, only based on denominator, that is Q. Okay, take one more example. Suppose 7 by 5. Okay, then P by Q. Then what is the value here? Q, 5. You can write in the form of 2 power n, 5 power m. Okay, Q is equal 5 power 1 into 2 power 0. Therefore, 7 by 5 is in the form of 2 power n and 5 power m. 7 by 5 is a terminating decimal. Is it clear, students? Terminating decimal. Very simple. You can take any type of problem. Just see what is q. That is denominator. Is it have in the form of 2 power n and 5 power m? Suppose is it have in the form of 2 power n and 5 power m? Is a terminating decimal. Suppose is it not in the form of 2 power n and 5 power m? That is non-terminating repeating decimal. Now, I hope to clear this terminating, how to convert rational to decimal, decimal to rational, and using this trick, let x say p by q rational, and where q is in the form of 2 power n and 5 power m, where n and m are non-negative integer. Now, terminating, how to convert rational into non-terminating decimal. Okay, students, now give some example of terminating decimal. Very simple. Give some example of terminating decimal. 3 by 8. Okay. 4 by 20. Okay. 5 by 60. Right. These are non-terminating decimal. Now, terminating decimal. Now, non-terminating decimal. Non-terminating repeating decimal. Okay, let's see one example. 1 by 3. Okay, 1 indicates P, 3 indicates Q. 1 by 3 is nothing but divide 3. Here also same. See here, divisor is smaller than dividend. Then you can write here 0, 0 point. Okay, 3 3s are 9, 10 minus 9, 1, same. Here decimal point, then you can write one more 0, 3 3s are 9, 1, then we get same value, means 1 by 3 is a rational number, then what is the decimal? 0.333, so on, means here non-terminate. Non-terminate means the process will continuous goes on, right? Therefore, you can write 1 by 3 is equal 0.3 bar. Okay? You can simply identify when bar is there on decimal number, that is non-terminating. Okay? 1 by 3, it is a p by q value. Then what is the decimal value? 0.3 bar. Okay, student, is it clear? Then how to find without doing actual division given number is terminating or non-terminating, we will see in next class. Until then, keep on watching ABC Educational Learning App. Thank you.